The course that I'm teaching is MENG 3531, Introduction to Mechatronics. The whole purpose of this course is to provide hands-on experience to our students on mechatronics, which is about most of the modern systems that senses its status and also process those information to make decisions based on those, such as motion control or temperature control and so on, and also display those. When I came across the news articles that was saying some pharmacies are seeing shortage in pulse oximeter when the pandemic first started, I knew that there were these sensors also attached on my cell phone already. And I thought that implementing this into the mechatronics course that I'm teaching will be a perfect example of a system that can sense these signals and also analyze the data to display the information about your heart rate, heartbeat rate, and also the blood oxygen level. And we could also see how things we learn in the class could be applied in real application in the context of COVID. The Department of Mechanical Engineering and the Faculty Development Committee has supported this idea, and we immediately started to implement this into the course.
So in this series of labs, we started working with microcontrollers, specifically the Arduino-Uno, and we started out just the Arduino reads an input from a button, and then it turns on a light, and then from there we built on that to something that's been on smartphones in the past and it's on smartwatches now, the pulse oximeter, which you just put your finger on a little sensor and it reads your heart rate and your blood oxygen level. And it was displayed on a little LCD display that we connected to the Arduino. And it also had a small buzzer, so anytime it took a reading, it gave you a little buzz to let you know it was taking a reading.
One of the highlights of this class for me was definitely the pulse oximeter, with that uses heart rate as well as the blood saturation levels. Now, in a time of like COVID, you could clearly see how stuff like this could be used in your everyday lives, especially in like the healthcare system.
I am passionate about medical devices, and this lab has actually helped me understand how to use the mechanical system side and the circuits and logic gate side in combination to help me understand how this works.
I definitely think the methodology would be transferable to different things, if not the main content itself. Just being able to kind of extrapolate that way of thinking to different projects is pretty cool.